Hi, my name is Tom Hoeffel, and this channel is all about helping students learn chemistry. In this particular lesson, we're going to be continuing our conversation on molarity and stoichiometry with two more advanced problems than the one that we did in the last video. So the prompt here asks, hey, if we have 2 grams of zinc and it reacts with 5 milliliters of 0.15 molar hydrochloric acid in a single displacement reaction, what's the limiting reactant? What's the reactant in excess? How many grams are left over of that reactant excess? And what's the theoretical yield of zinc chloride in grams? So this is just a combination of the molarity equation and stoichiometry that we did before with limiting reactants. So if you don't understand limiting reactant problems, you might want to go back to a previous lesson on limiting reactant and limiting reactant practice problems. All of the lessons are in the description of this YouTube video. So to start this problem out, I need a balanced chemical equation. So I'm going to start with balancing the chemical equation as such. Okay, so I have zinc and hydrochloric acid making zinc chloride and hydrogen. Hydrogen's diatomic, and the right formula for zinc chloride is ZnCl2. So we get a coefficient of 2 here. The next step here is I'm going to take all of the givens here and I'm going to put them in boxes underneath each chemical. So I got 2 grams of zinc and 5 milliliters of 0.15 molar hydrochloric acid. Okay, and the question's asking about the theoretical yield of zinc chloride. So to do this, okay, I'm going to do some stoichiometry to get my grams of zinc into grams of zinc chloride by going from grams to moles, moles to moles, moles to grams. Okay, and I'm also going to do that with the hydrochloric acid. And I'm going to use the molarity equation here, okay, to get it into moles of HCl, then moles of HCl to moles of zinc chloride into grams of zinc chloride. So this is the way that that's going to look like, okay, when I do that work. Okay, so the 2 grams of zinc, if all of it reacts, I can make 4.17 grams of zinc chloride because of these train tracks, stoichiometry stuff that I've done before. If I do it with the hydrochloric acid, the first thing I need to do is get the milliliters into liters. So if I divide by 1,000, I will find out that 5 milliliters is equal to 0.005 liters. And then I take the molarity, okay, and if I cross multiply, I get moles is equal to molarity times volume, and I multiply these out, I find out that the volume and molarity will be equivalent to 0.007 moles of hydrochloric acid. And I'm going to convert that over to zinc chloride to see how much zinc chloride I can make. And as you can see, I can only make 0.0512 grams of zinc chloride. So this becomes my theoretical yield, okay? Whichever is the lower of the two, okay, ends up being your theoretical yield. So the reason for that is that I'd run out of hydrochloric acid, okay? And if I run out of hydrochloric acid becomes the limiting reactant. Zinc is the reactant in excess, which means some of the zinc reacts, but some of it does not, okay? And then my theoretical yield is going to be 0.0512 grams of zinc chloride. So just by converting both of these over to a common product and comparing them, I can answer a majority of these questions. What's the limiting reactant? The hydrochloric acid. It runs out first, okay? The zinc, there's just more left over, okay? And since the hydrochloric acid runs out first, the reaction is going to stop when 0.0512 grams of zinc chloride has been produced. And then the reaction shuts off because you have no more hydrochloric acid, okay? Well, there's one more question. They're asking, well, how many grams of zinc is going to be left over? We know some of the zinc's going to react, so it's going to be less than 2 grams, okay? But how much is going to react? And if we can figure out how much is going to react, then we can figure out how much is left over. So in order to figure out how much is reacted, we're going to take our limiting reactant, 0.00075 moles of hydrochloric acid, and we're going to convert it over to zinc. Okay, and when I do that, okay, 0.00075 moles of hydrochloric acid converted over to zinc, I find out that 0.245 grams of zinc reacted, because if this much hydrochloric acid reacts, then this is how much zinc reacted. Well, if I started with 2.00 grams of zinc and 0.0245 grams of zinc reacted, then this is going to tell you how much is unreacted or left over. So here are all your answers. Limiting reactant is hydrochloric acid. Zinc is the reactant in excess, okay? 0.0245 reacted, so 1.975 grams is unreacted, okay? And then the theoretical yield is 0.0512 grams of zinc chloride. So that's a limiting reactant with using the molarity equation, okay? The second problem that I have is a neutralization reaction. We see these types of problems with titrations a lot, okay? And this is going to come down to how many milliliters of 0.602 molar hydrochloric acid are required to neutralize. And that just means reacts with 31.5 milliliters of 0.301 molar sodium hydroxide. So like I said, I like to set my problem up, okay, where I put all of the givens in boxes, and then I like to put an underscore for what the prompt is asking. The prompt's asking how many milliliters of the hydrochloric acid. So I'm putting that under the hydrochloric acid. So the first part here that I'm going to do is I'm going to figure out, well, how many moles is this? Because I have molarity and volume. I'm just going to use the molarity equation to figure out how many moles of sodium hydroxide I have as a given. Now, when you use the molarity equation, it can't be in milliliters. So the first part is I'm going to divide that number by 1,000 to get it into liters. So now that I have it in liters, I'm going to use the molarity equation, and I'm going to plug in the molarity and the volume to get the moles. Right here's my molarity, and the volume, remember, I'm going to use is going to be the one that's in liters. So when I cross multiply, I get moles is equal to molarity times volume, and I find out that with this amount of sodium hydroxide, that is equivalent to 0.00948 moles of sodium hydroxide. I think I got a little ahead of myself there by the labeling. Okay, so all of this is sodium hydroxide. Okay, well, if this amount of sodium hydroxide is going to react, there's a certain amount of the hydrochloric acid that's required. So I'm going to take that 0.00948 moles of sodium hydroxide and convert it over to moles of the other reactant. And as you can see, it's a 1-to-1 ratio. So it's the same amount of hydrochloric acid as it is sodium hydroxide because of that 1-to-1 ratio. So when you multiply 1, divide by 1, you get the same number, but you can see that the moles of sodium hydroxide are canceling out, and I have moles of HCl. Well, if I have moles of HCl and the molarity of HCl, then I can figure out the volume of HCl using the molarity equation. Okay, so I'm going to use the molarity equation. I'm going to take these moles, plug it in right here. I'm going to take this molarity and plug it right in here, and I'm going to solve for volume. Okay, so if I'm solving for volume, I'm going to cross multiply first, and then I'm going to divide both sides by big M. Okay, so volume is equal to moles divided by molarity. Here are my moles. Here's my molarity. And when I figure that out, I find out that I need 0.01575 liters of HCl. But the prompt, remember, is asking for milliliters. So I just do some converting there, and I convert the liters into milliliters, and I find out that it's actually 15.75, but I just rounded it to 3 sig figs because we have 3 sig figs in our given. So approximately 15.8 milliliters of hydrochloric acid is required to neutralize the sodium hydroxide. I hope this information was helpful doing these two accelerated problems where we have the molarity equation and the stoichiometry mixed together. So all we did here was take two concepts that we already know and we put them together. If this information has been helpful, please like and subscribe. Even adding a comment really helps the YouTube algorithm. Send this out to other students that might be interested in learning some chemistry.